Welcome to my the 22nd episode on the collections uh, and what we are going to do now is uh, we are trying to get one more aspect of streams now is that we have an enhanced for loop and most of the times we start ending up putting for loops within for loops. Then we try to create variables inside that, initialize that. Those all does really cost us a lot of performance trade-off. uh, I will first take an example of string variables. What happens if we create string variables inside enhanced for loops, and how can we avoid that by using streams? That's what we are going to discuss today. So in the next example, we are going to talk about an enhanced for loop, and we will take an example with a class which is going to replace the enhanced for loop with streams. So let's say we have an example here. uh, I'm not going to type each and every word because it's going to be very boring for you. So I just did a copy paste for this, and I'm going to declare a name method public static public public static replace this by main. uh, and we will also rename this program to a meaningful name. We're going to say this is test 356. We need list. We are going to import that. Then we need list java.util. We did that, and then list dot new array list. So in this one, what we are going to do is that we are going to take first a enhance for loop. We are doing a task which is we are going to replace all the names which starts with B using an enhance for loop, and then we are going to do the same operation with the streams. Now here the objective of this episode is not to compare the performance of stream and enhance for loop. That is not the objective of this task. The objective of this task is, if somebody gives you an enhanced for loop, some task was doing with enhanced for loop, how do you replace this using streams? We will have another episode where we are going to actually compare the performance of an enhanced for loop with streams, and then we will discuss under what conditions you can use enhanced for loop or ordinary for loop, and under what conditions you can use streams or parallel streams. But for this one, we're going to stick with just understanding. So we are trying to understand the different, you know, things given by streams API, and in this case, how do I, replace this with streams?
Recording in progress.
So what we have done is we have an array of strings, and what we're going to do is that we will be uh, iterating through this, and whosoever spelling starts with letter B, we are going to remove that. So how we are going to do that? We are going to capture the names on a list, right? And then we'll have a new array where we'll have the totally processed list where we have removed the name starting with B. So let me repeat if I was not clear enough. We are going to take an array or list of names, and whose name starts with B, we are going to remove that names from that list and have a new list without those names. How we are going to achieve this? So the way we are going to achieve this is that we are going to go through a for loop here. Whose name starts with B, we are going to add to another list here, and then what we are going to do is that we are going to go back to the original list of names and we'll remove all those names from there. Uh, we are not going to discuss whether this algorithm is efficient or not. It can be done in a better ways. No, we are not going there because that's not our objective. Our objective is, if a task is given to us with the for loops, how do you replace this with streaming operations? So why we are doing this? While we are doing this, we'll realize, how we have to implement streams. So we have this enhanced for loop here, and the condition we are saying if its name starts with B, then we are going to add this to the B names list here, and then we're going to go to names.remove, and then we're going to add this list. It's going to remove. Let's see whether this code works for us. Okay, now we will first rename this to enhance for loop. For loop example, and rename this Java to enhance for loop example. We are going to format this. Now uh, we are getting an error of this in saying unsupported operation exception abstract list dot remove. So can we not remove all B names? Okay, so looks like our example line number 20 is not supported. No problem, we'll troubleshoot this and we'll find a means to remove this.
Recording in progress.
So when we run this program, we are getting an exception. It says unsupported operation exception. Now the question is that why is it saying me that it's unsupported operation exception? So when you say arrays dot as list names as a list, you are actually fixing the size of this list. Names and in such a condition, let's go back here, arrays as list. If you see this, it says that it provides a convenient way to create a fixed size list initialized to contain several elements. And then once I create the particular size, it is not going to be mutable. It is fixed. So when something is mutable, immutable, and it's immutable, right? It says returns list of a fixed size. If I try to remove something from here, it's going to give me a unsupported operation exception. So how do I resolve this issue? So in order to resolve this issue, we are going to remove this restriction of fixed size. How do I do that? It's very simple. Give a new array list and put this, let it go to the constructor. And then let's run this program. But before we run this, we need some output. So how do I put the output? The most simplest way is system dot out dot println the list is dot. Is there a method, to print everything? Stream sublist array sort comparator notify all. So there is a for each method. We can use this for each. Let's say t. So we can replace this b names dot for each t dot sorry names dot for each p dot. So we are going to use the for each method of this one to print everything. And the easiest way to do that is use system.out.println. And the way we did is we do is that system dot out dot println. Would this work? Let's see. Yes. So we are able to now remove what is there inside another list using remove all. First we got an exception because the way we had declared array list was of fixed size, so it became mutable. You cannot change it. That's why we made it as, sorry, we made it immutable. So we made it mutable by having the new array list. Now, how do I do this using streams?
Recording in progress.
After achieving this of enhanced for loop, now we are going to have a similar example with the streams. So let's copy this class. Test TS test 446 is the new class, and then we are going to copy the previous code which is there here, and as for loop into this one, entire code, and then copy this here. So this is the enhance for loop, and then this is ending here and the class ends here. Then we will name this as not enhance for loop. We'll say this as replace for loop with string. Replace for loop with stream. With stream. So now we have the method made cannot be declared, static method cannot be declared as static level or top level. Why does this say that? Because we have two classes here. That's the reason. So you replace this, and then we'll rename this Java file. Rename to with stream example. Now just we are going to comment this for loop, and before that, first we will try to format the source. Let's go to source and then correct indentation, and then we are going to format this source, and then now what we're going to do is we're going to think on how do we do using streams. Now in this for loop is source, and then add block comment. We are purposely keeping this for loop here, but I think let's comment in a proper way. Now
Recording in progress.
so let's take this as step by step. So we are going to take the stream names, and we are going to, I think we don't need this for now. Here and then here also, then we are going to have this names. We're going to convert this to a stream dot stream operation. When we go inside the stream, now we have to do a filter. So let's put the filter here. What are we going to filter? So for each t, let's say this t is braces, then we put a lambda here, then t dot starts with, yes, starts with, and then we're going to say this as b, and names dot stream dot filter t starts start with b. We're going to filter this, and then what we're going to do, so we are going to say a negative condition, and then we're going to put this to map, or we can put collect and put that in a list.
Recording in progress.
So there is a collect operation here, dot co collect, and it is going to give us an argument where we can collect this in a list, right? We say collections dot list, right?
Recording in progress.
Collectors dot to list. So we are going to collect this in a list, and let's name that list as b names, right? We already discovered this. Can I equate this to this one? Okay, so what I did a filter for each. Let's, instead of calling t, let's call this as each name. Makes our code more readable. Name, name.t with b. See the freedom, I can give any name, variable name here, right? I was able to replace t with names. Now I got b names here. So I just uncomment this. Would it give me the same output? So remember that we did only one operation here. Uh, Two operations. One is I just filtered this and then I made a list. I collected this inside the list. And the one I collected is b names, right? So I need to give b names. I can do the for each here, or I can have a separate for each. For just for the clarity of the program, we will keep this as separate. Let's try to print it. Okay, let's see. Yes, we got it. So we got all the names which are not starting with B. So what we achieved here is that uh, we used a string instead of the enhanced for loop, and this is still possible with just one operation. That means I can, you know, comment this one also and just give this for each here. Can I do this? So I'm going to take out this B names, and then would this work? For each. We have an issue. What is the issue? So for each is matching with this. This is matching with what? This is not matching with anything. Can I declare this way? What happens? Would it work? It is working, which means I don't need another braces here. Would this work? No. What does it say now? Syntax error. Oh, no, I did something right. Does it do a quick fix for me? No. So name starts with B. I think we prefer to have this inside the braces. So this has a opening brace and close brace. Then this has a brace, this has a brace, and then we are collecting this. I remove this, the error is gone. So whatever I need to do, I have to do this after this brace. Let's see if I get dot for each here. It is there. And can I put this one there? And will this work? There's no need to print here in a separate list. I'm converting this to a list and then I'm putting a for each, so I'm going to get the output also, right? But if you want to put that in a different list and then print it, you can do it. Let's see the output now. There you go. So what we try to achieve with the enhanced for loop and then operation remove all and then print was possible with just single command line with streams. One thing very important is that when you work with streams, you have to give meaningful variable names. Otherwise, the readability of the program is immediately lost, because when you use streams, right, you don't know, people generally don't understand, who have worked on Java 7 and all, who are used to Java 7, they don't understand what are you doing here. So it has to be readable. In my next episode, we are going to have a total touch up with the uh, streams. But before that, let's clean this program. You don't need this, right? So I'm going to comment this. You should not leave a program like this. You want to comment something. This looks very nasty, so it's better you format this. Source, correct indentation, then source format, make the code readable. So I purposely kept the commented statement just to see that whatever we have, what operations we did, we uh, we commented those on how we can achieve this using streams. So before we end this episode,
Recording in progress.
so before we end this, we're going to have a look at the streams, what all we did until now. We did we did an introduction to streams. We realized that stream is a pipeline. It has intermediate operations. We can source a stream and it has terminal operations. We can also use parallel streams. So one thing we have to remember, that streams are not containers and streams are lazy. Then we have different methods in stream. We studied map, we studied filter map. We have not yet seen reduce. We are going to see reduce. We are going to have the flat maps, and we're going to go a little more depth for parallel streams. Until now, I just showed you how to have parallel streams, but we haven't really dealt a full-fledged example of what exactly you do in parallel streams. Then we will deal some more methods uh, in the streams, and after that we will talk something about performance. uh, when we do Java coding, it's seeing performance as a separate phase, and somebody doing performance testing for us is a costly affair. So we will see an example of how to write a JUnit test and how to, it's a simultaneously using some annotations, how we are going to, measure the performance of our programs. That we need to see. Because imagine that some some days are going to come where people are saying, going to say, hey, no, we are not going to have a separate phase for performance. It's very costly for us. You have to take care of the performance as you code. So how do you handle that? You not only test functionality with methods or integration testing, but you will have to test the performance of your methods also. How you're going to handle that? We're going to discuss about that also in our coming episodes. If you like this, subscribe, hit the like button, and hit the subscribe button. Thank you all.